Hi guys, in this session you are going to learn about proc univariate. The following are the produced by proc univariate and it's more helpful for creating graphs. They are, first one is a moment, it is for n, mean, standard deviation, etc. And second one is the basic statistical measures like mean, median, mode, standard deviation, etc. And third one tests for location like a student sign and a signer random test, etc. And fourth one is a quantiles. It means it gives some values at a particular percentages. And the next one is an extreme observations, nothing but the lowest 5 and highest 5 values in the data set. For understanding about a proc univariate, we take example from SAS-help.class and I named the dataset demo. We are running this code. Before opening dataset log is clear. We are opening demo. Here we have a class dataset named demo and now we are applying proc univariate on this dataset. Now the syntax for proc univariate is proc univariate data equals to origin data semicolon var variable list semicolon and run. We are running simple code for that. Proc univariate data equals to demo is nothing but class dataset here. Var is the age and run. On age variable we are applying proc univariate and we will produce the following 5 major information. Now we are running this code and the first one is the moments and second one is the basic control. In that first one n is nothing but number of observation, already we know, mean, standard deviation, skewness, uncorrected SS, and the second one is the basic statistical measures, and third one tests for location, and the fourth one quantiles, nothing but a particular percentages and the value, and fifth one is the 5 lowest values and the 5 highest values. Like this we get information. Here simply proc univariate is a combination of proc frequency and proc means, and proc univariate will done both jobs whatever done by the means and frequency with some extra information, and it's a more useful for while creating graphs. Here we have the following 5 types of information, but we can restrict the following. It means, for example, if you need a only movement or only tests for location or only for extreme observation, like this type of situation, we can restrict the following information. Then how it will be, and before restrict the output, we have to know some particular names for this. It means here the movement is there, but if you directly give a movement, it doesn't take. There is another name for restrict this output. Then what are those? For the moments is the moments. For the basic statistical measures, just basic measures. And tests for location mu equals to 0, tests for location. And quantiles is just nothing but quantiles. And for extreme observations, extreme OBS. And we have to remember these codes for restrict the output. Then how it will be? ODS select. I just select a movements, got it? I need only movements in the output. Like that we can restrict the following output while creating a proc univariate. Now we run this code. Proc univariate data equals to demo var age and run. We are running this code including ODS. Yes, here we are only get the movements. Why? Because I am restrict here for output. Now just like that we can restrict the another one also, and just restrict extreme observations proc univariate. Again you have to write the each code var age and run, and while running you have to include the ODS select also. At that situation only you get restrict the information. Like this we can restrict the output. In the proc univariate we can add ID also. Then how it will be? Proc univariate data equals to demo var age and ID name and run. And while discuss about a proc univariate, I am already telling you that these only for the numeric data like a means. Why? Because it's a statistical for creating a graphs, and here ID you can use both the character and a numeric. Running this code just like some additional information is getting by the ID. It did nothing here like a transpose, we have some other purpose for ID, but here it is a concept is a different for ID. And just like a proc means, we have a by statement, we have a class statement in a proc univariate also, but very slight difference here. In a proc means class is used for the compare, and a by is generally it's for grouping the variables. First we do the by statement, and whenever you use by, we have to sorting it first. Data equals to demo by sex and run. And again we write a proc univariate. Data equals to demo var age and by sex and ID is the name and run. Here I am just grouping the output. And before that, how we get an output here? Based on a age variable, we are getting each and every information like a movement, places, statistical and everything. Now I am grouping that all the information by the sex. We are just running this code with including sort. First we get sex equals to F movements, every information based on sex equals to F. Next from here sex equals to M. Now when we using by statement here, it is grouping the information. Totally is the same, it's just separate that information based on the by variable. And just like a by class also do same thing. Proc univariate data equals to demo var age and a class sex, ID is the name and run. We are running this code. Yes, just like we are get same information based on F. Got it? From sex equals to F here and x equals to M. Like this we can grouping the information based on some particular variables. And here we are getting some extreme observation when we run proc univariate. Especially we can control this extreme observation. Like here we are getting 5 observation based on one variable, and like that we have a control for extreme observations. Then how it will be? Here the SAS default assign 5 highest and 5 lowest extreme observation, and here we can control that whatever the number you need. Proc univariate data equals to demo next ROBS equals to 3 and var age, ID is the name and run. We just add next ROBS to restrict the number of observation in extreme observation. We are running this code. Previously we are getting randomly 5 observations for extreme OBS, but when we give next ROBS, it only get 3 observation. Why? Because we are restrict this number of observation by next ROBS, and we can get some frequency and order just like a values. Then how it will be? Proc univariate data equals to demo next are values var age and ID is the name and run. We are running this code. Here we are not mentioned next ROBS. As default it gives the 5, but we can restrict here. What we restrict here? We restrict 3. That's why we are getting the value that is 11, 12, 13, only 3, and frequency first 3 lowest, first 3 highest values. Like this we can control the observations and the values by using next ROBS and next R values. And here we can use the round. Already we know that round is the nearest value. Then how it will be? Proc univariate data equals to demo round equals to 3 and the next ROBS equals to 4, next R value equals to 4, and var age, ID is the name and run. Here if you observe values rounded nearest to the multiple of 3, it means when we multiply with 3 we have to get the remainder is 0. That type of values are assigned here. Just like a 12 we are getting remainder as a 0. For the 15 also we are getting remainder as a 0 in the total highest and lowest only, not according to the total table. These are the 5 highest and 5 lowest values. Here 11, 12, 13 is there, and there is the only one value that is a 12 nearest to the 3. It means when we remainder is 0, and here 15 is like that. That type of, that is the meaning here, rounding the observations. Got it? and 15 also like that. In that 5 only, it's not include the total observation in a data set. Keep it in mind. And the values also like that. That is a round. Are you understand what is a round here? Simply the nearest values multiply of 3. When we multiply with it, whatever number you give, if you give a 4 or 5 or whatever number here, that's a your wish. And simply that values only, that too from the highest and lowest, whatever the 5 system default given only. In the next one already we discussed that proc univariate will do whatever is done by the frequency and the means. First we go with the frequency, proc freq. First we write a proc freq, data equals to demo, tables age, enter. We are running simple code of proc frequency. Here is an output. This is the output for proc frequency, and this will be same done by the proc univariate also. And try to capture it. Now we are go with the proc univariate. Proc univariate, data equals to demo, frequency, var age, id name, run. We are running this code. We are just add a freq for getting the frequency information of that particular age variable. Here we are using a table. Here we are using a var. We are running this code. Here this is the frequency counts here, and this is the count is nothing but frequency here, and a cell is nothing but the percentages. Cum is nothing but cumulative percentages. And the next one we check with the means. For getting the frequency information, we just add a freq. Now we are go with the means. Proc means, data equals to demo, var age, and run. This is a simple code for means. Now try to capture this exact information by the means. Now we run the same variable proc univariate. Then how it will be? Proc univariate, data equals to demo. I am just giving a no print. Var equals to age, var age, output, out equals to demo 1, mean equals to mean age, std equals to std age, median equals to median age, minimum, maximum, and n. Enter. And when we run this proc means, what are the default variables? N, mean, standard deviation, minimum, maximum. Already we discussed this. Now I am just need that same information, that is a mean equals to, this is the variable name, whatever you want you should give. And std also same, std age, this is the user defined name. You can change whatever the name you want. Just like that, I get a mean, standard deviation, median, minimum, maximum, n. In the output, we are running this code. Before opening dataset, log is clear, demo 1. We are getting the same values, n, 19, mean, standard deviation, and age, and median, minimum. Minimum is 11, we know that. Maximum is 16, we know that. Median is 13, and standard deviation, and a mean, and n. Like this, we get the information whatever we get from the means also. Here we are getting only one variable information, and if you want to more than one variable, that is also same, but a small change, that is a proc univariate, data equals to demo, no print. I just no, I don't need an output for this, that's why I give a no print, var space age space fact. I just mentioned another variable, just like a means also we are same mentioned another variable like this, and output out demo 2, and here mean equals to mean age space mean height. No need to write again a mean, just write a mean space age another variable. If you want another, you just mention here another variable, you just add another variable. And the standard deviation also like that, median, minimum, maximum, n, and run. And whenever you increase the number of variables in a var, you have to increase the number of variable here also. We are running this code. Before opening dataset, log is clear, demo 2. Yes, this is the n of age, n of both are same, that's why because both are coming from the same dataset. Age mean is different, we know that. Height mean also different. And if you have a doubt about it, cross compare to the means on a height, and again check with the univariate, you get a same result. Now we can control the quantiles also. What does quantiles here? It gives the values at some particular system defined percentages. But if you need between 50 and 75, the 60 is there, if you need that value, or at a 26 like that, what is the value at the 26 percentage. Like that you get information also. Then how to restrict that particular percentages. Proc univariate data equals to demo. No print, I just give a no print where age output out equals to demo 3, mean equals to mean age. I am just adding some extra statistics here. Mean, median, standard deviation. PCT LPTS equals to I want value at 25, at 55, at 95. Got it? Then next PCT LPRE is nothing but the variable name. Whatever you mention here, that will be reflect in the variable name. Now we are running this code. Before opening dataset, log is clear and demo 3. Yes, at 25 is a 12, at 55 is a 14, at 95 is the value is 16. We are just a cross check with the 25 and the 95 percentages is the value same or not. At the 25 is a 12, at 95 is a 16. Keep remember it. 25 12, 95 16. We cross check with an output. At 25 is a 12. At 95 is a 60, and like this you can get wherever the percentage you want. And just like that we get not only a single variable, we can get the number of variables percentages at a time in a single data set. Then how it will be? Proc univariate data equals to demo, no print where age and height. I am just getting age and height percentages at some 25 95, and data equals to demo 4. I am just adding some extra statistics. Now PCT LPTS is the same, and PCT LPRE equals to first variable name include with the age underscore, and the next height will be included height underscore. Now we are running this code. Before opening dataset, log is clear, demo 4. Yes, you get age 25 is a 12, height 25 is a 57.5. We are not running this height statistics, and 55 age, 55 height. Like this you get some particular percentage values. And if you need each and every numeric variable in a data set, then how it will be? Proc univariate data equals to demo and just run. When we mention var is used to restrict the variable here. Whatever the variable you need, we just use in the var statement. But when you ignore the var, it includes the all numeric variables in a particular data set. Then yes, here it is start. First one is an age. We are getting total age information, and here is a height. And already we know that in a demo data set we are only 3 numeric variables, that are age, height and weight. And in the output also we are getting like that. First age is completed, next one height, the next one go with the weight. Like this, if you ignoring the var statement, it includes the all numeric variables from a data set. And already we discussed that it's the most helpful in a graphs. Then how it will be? For graphs, proc univariate data equals to demo var height and histogram height and run. This is a one type of graph, and like this we can use the proc univariate. If you need the remaining procedures in a SAS, visit my channel at once. You definitely like that. Please subscribe my channel, click the bell icon, like the video and comment below, share with your friends. Thank you. Support me.